Howdy, y'all. I am so sorry that I can't be there with you today. So I figured that I would record a little video to get you guys ready for the quiz next class. Now remember, it's going to be a teeny tiny quiz. It's just going to be over whether or not something is a function, and then using a story to create a graph. So I know that I talked through the worksheet with A Day, and Miss Castile talked through the worksheet with B Day, the worksheet on whether or not something is a function. So I just want to make sure that you know how can you tell if something is a function? Well, there are two ways to do this. First of all, you can just look at the graph of a function. So here we have two graphs. Boom. And then you're going to do what we call the vertical line test. And we call it the vertical line test because we're literally just drawing a vertical line to see if it hits the graph more than once. And if it does, it is not a function. So let's look at this first graph right here, this guy right here. So I'm going to draw some vertical lines, and I'm going to see if any of those lines hit it more than once. So here's a vertical line right there. It hit the graph one time. Totally fine, no problem. Draw another vertical line. Hit the graph one time. No problem. Draw another vertical line. It hit it one time. No matter where I draw a vertical line, it's only going to hit the graph one time, which means, yes, this guy is a function because it passes the vertical line test. And you want to make sure you tell me how you know it's a function. So I'm going to go ahead and say, because it passes the vertical, oops, I can't spell, vertical line test. Okay, shablam. Now let's go look at this other puppy over here. So when I draw a vertical line here, shablam. Whoa, I hit the function 4 times with that vertical line. So I automatically know that no, this is not a function because it fails the vertical line test. So because it fails the vertical line test. For your communication grade on this little mini quiz next class, you do need to be able to explain to me how you know it's not a function. So don't just say yes and no. Tell me, yes, it is a function because it passes the vertical line test, or no, it's not a function because it fails the vertical line test. Okay, so that is the vertical line test. If it only hits once, we're good. If it hits more than once at any point on the function, and I should say that at any point. So if I have something, a little function that looks like this, let's say I'm all just like la 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 la, boop, la 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 la, and I'm like, toads looks like a function, but right here, right in the middle, right here, if I drew a vertical line through that section, boom, I'm gonna hit 3 times right there. So it doesn't matter that all of these vertical lines only hit it once. If there's any point on the function where it hits more than once, then it is not a function. Okay, so that's how you know by looking at a graph. So what if you don't have a graph? What if you were just looking at a set of ordered pairs? So when you're looking at ordered pairs like this set right here, we need to think about what we're actually looking for. So in this case, we are looking to see if I have any repeats for x. So a function is a function if and only if each x is paired with exactly one boop, 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 y. So each x has only one y. An easy way to think about that is we have no repeating x values. Because as soon as we have a repeating x value, that means that we have an x that has gone and paired itself with more than one y. So if we look at what we've got right here, this ordered pair set that I wrote up here, I have 2, 6. So I'm looking at only my x values, 2 and 6, 3 and 5, cool, 4 and 9, so far so good, 3 and 7, wait, what? Y'all. Dun 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 dun. This is awful. I have 2 x's that are pairing with 2 different y's. I cannot have this. I cannot have repeating x values. This means that this set right here is not a function. And your explanation can be something along the lines of, because I have repeating x values. Repeating x values. So this is a big no-no. Another way you can think about this is if you're looking at a table of ordered pairs or values, sorry. So let's say I had 1, 2, 3, 4. I'm just making up some numbers here, which is dangerous, but I'm going to do it. So looking at this little table of values, again, let's look at our x values. 1 is paired with 5, 2 is paired with 6, 3 is paired with 7, 4 is paired with 8. Did any of those x values repeat? They did not. So guess what? This is a function. Yay! This is a function because there are no repeating x values. X values. Okay? So that is it for function out of function. Vertical line test for graphs, looking for repeating x values for ordered pairs and tables. If you can do that, you are good as gold. Okay, y'all, let's go look at drawing some graphs from a story. Shablow! Okay, so I'm hoping that Miss Castile went over number 1 with you on your worksheet from class, the one about what's-her-face going to the store but realizing that she forgot her money and that she had to come back after going halfway. So I'm going to do number 2 and 3 with you, and then you can look on Canvas for the key for the rest of them. So Rashid is jumping on a trampoline. Graph time on the horizontal axis and his distance off the ground on the vertical axis. So let's go ahead. I know, oops, you have a graph. I have to draw a graph here. Can I do, oh, do you think I could do a line? Yeah, I can do a line. Oh, no, I can't do a line. Okay, sorry, I was exploring my tools, but I can't do a line, so I'm so sorry that you had to listen to me do all those noises. So here we go, and here we go. Pretend that's straight. Okay, so they have told me that they want time on the horizontal axis, so that's going to be this axis down here, and his distance off the ground on the vertical axis. So this is going to be distance over here, distance. Now, to get a 4 on this little mini quiz, I need you to use numbers. Now, I will either give you numbers to use in the story, or you need to make up some numbers that make sense. So, for example, Rashid here, if he's jumping on a trampoline, he's probably not going to jump 30 meters into the air on a trampoline. The last trampoline that I was on, I grant you, was like 17 years ago, but the highest I got was maybe 8 feet. When I was super, 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 super jumpy. So I'm going to put my distance at a max of, I think we're just going to say 6 feet. So I'm just going to do 1 foot incrementals here. Incrementals? Increments, I think is what I'm trying to say. I'm going to say that the highest that Rashid is going to get off the ground is 6 feet. So I'm going to go ahead and mark that I'm using feet there. And then time, if you think about somebody jumping on a trampoline, how long does it take them to go up and down? Are we thinking seconds, minutes, days, weeks? Hopefully, again, we're going to try to be reasonable. If somebody's jumping on a trampoline, it does not take them a whole minute to go up and then come back down. That's if you're jumping on like Mars or something like that, where the gravity is scarce. We are jumping in real life here on the Earth. So I'm going to say we're going to be using seconds here. Also, I just realized that this is making a terrible clicking noise every time I write. I'm so sorry about that. So here we go. So this is going to be 1 second, 2 seconds. I'm going to say that Rashid is going to take about a second per jump. So it's going to take him about a second to go, jump. It's a second to go up and down, really. So let's say that the trampoline, when he's standing on the trampoline, he's 1 foot off the ground. Let's say it's one of those little baby trampolines. So at 0 time, he's right here. right there, standing on the trampoline. And then he's going to start bouncing. So he's going to jump, and he's going to go up in the air. And I'm going to say, he's going to get a good jump. I'm going to say he's going to get about 4 feet in the air for that first jump. And then he's going to go 4 feet and come right back down. Now, when he comes back down, so here's 4 feet. It's going to take him about a half a second to get up yonder. When he comes back down, y'all, I'm going to say that if you think about a trampoline, when you hit the bottom of the trampoline, so here's a little trampoline, when you come back down, right, the trampoline kind of like it dips down with the weight that you bring under it. So I'm going to say when he's coming back down from here, he's going to actually go a little bit lower than where he started before he bounces back up. Right, so I'm going to say that he came. Oops, I was trying to do a pen there. I'm going to say that he came and he sunk maybe like 6 inches closer to the ground, and then he bounced right back up. So we're going to go. And he bounced right back up, and he went back up to 4 feet, and he came back down here, and he bounced right back up to about 4 feet. And I'm going to give him a constant height. If you think that maybe his height is growing, maybe he's like hitting a little harder every time, you can do that. You can like make it get a little higher every time, but remember, just keep it within reason. Now I have put these little points right here. You do not have to have those points. Yours could all look like this over here, as long as that graph makes sense, which that totally does. He's jumping up and down on the trampoline. So y'all, this right here, I have labels on both of my axes. I have numbers on both of my axes, and I have an accurate representation of the story. So I would say that if you did this on the quiz on Tuesday, you would get a 4 for this section. So use this as your guide. Let's go ahead and do number 3 real quick, and we'll be done. Okay, guys, so here's number 3. I went ahead and drew my graph so you didn't have to hear me work through all the difficulties of my iPad. So Kendra is speeding along the highway and is stopped by a police officer. Kendra, the officer gives her a ticket, and then she continues on her way. Graph time on the, where's my marker? Let's do this. Graph time, it's not working for me, there it is. On the horizontal axis, and then her speed on the vertical axis. So let's get down here and label our axes. I don't think I want green, guys. Let's go for, yeah. So I have time down here, and then I have speed on this axis right here. So again, I didn't give you any numbers, so you're going to have to come up with your own numbers, but let's be reasonable. So if Kendra was speeding along the highway, how fast do you think Kendra was going? I'm going to say, not that I have any experience with speeding tickets whatsoever, I'm just going to say that maybe she was going around 80 miles an hour. Okay, so that means my highest speed needs to be up at 80 miles an hour. So I'm going to do my speed in increments of 10. So 30, 40, 50, 60, 70, 80. So there's my highest speed right there. Now for the time of this whole interaction, again, not that I have any experience with speeding tickets, but I'm just wondering if maybe a speeding stop takes between 10 and 15 minutes. So that means if Kendra is driving and then she's stopped for 10 or 15 minutes and then she keeps going, I would think we would have a total of like a half hour going by here. So I'm going to put my time in minutes. And then I'm going to put my increments in 5-minute incrementals. Oh my gosh, why do I keep saying incrementals? Increments. Okay. Cool beans. So at the very, very beginning of our time, what is it telling us she's doing at the very, very beginning? Kendra is speeding along the highway. So that's the very, very start. She's speeding along the highway. And we have said, or I have said, that she's going to be going 80 miles an hour. So that's where we're going to be starting. And we're just going to assume that she's going constantly 80 miles an hour. So she's starting here at 80, and then she's just going to be cruising along at 80 miles an hour. Okay. Then she's stopped by a police officer. So let's say that the police officer gets her right around here. So just like 7 minutes or so. The police officer's like, whoop, 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 whoop. And so Kendra sees a police officer and like a law-abiding citizen, she slows her vehicle, pulls over to the curb pretty much immediately, and slows to a stop. So she is stopped on the side of the road. Now, we have said, or I said, again, from no experience whatsoever, I'm just taking a guess here, that Kendra was on the side of the road with the police officer for maybe 10 minutes or so. So we're going to say that Kendra is just sitting here, so her speed stays down here at 0 for just about 10 minutes. So I'm going to say it until we get to about 20. Her speed is just going to be 0 because the policeman's going to come up, she's going to talk to her. That all happens while she is stopped, so her speed is 0. Then the police officer says, "Thank you, have a nice day," and Kendra's going to start going again. So she's going to start accelerating to get back onto the highway, so her speed is going to increase. Now, if Kendra's a smarty pants, she's not going to go way back up to 80 miles an hour. She's probably going to take it slow. So I'm going to say that she's going to take it slow and hit 60 miles an hour and keep driving at 60 miles an hour instead of clocking it back up to 80, because she's a smarty pants and she knows that that's what the real speed is. Okay, so again, looking at this graph, if you did this on the quiz next class, I would give you a 4. This looks pretty good to me. You've got both axes labeled. Oh, Shuckleface McGee, y'all, look at this. I didn't label my speed. My speed is in miles per hour. Oof, that was close. Okay, so now it looks like a 4. So both of my axes are labeled. I've got numbers on both my axes. I've got something that makes sense with the story. She was driving at 80. She pulled over. She stopped. This is all her being stopped for these minutes down here. Then she slowly got back her speed up and then kept moving along right here at 60 miles an hour for the rest of her journey. Okay, y'all, that is all you have to do for the test on Monday. It is a test, but it's tiny. Or Tuesday, whatever it is, next class. So, what I would recommend is going to check out Canvas. I put the key to this worksheet and to the other worksheets you did in class up on there. So take a look at that, see what you need to see, and if you have any questions, send me an email. Y'all, you're going to do great. It's going to be easy. It's going to be fantastic. Rock and roll McDonald's. You are good at math, etc., etc. I will see you all on Tuesday. Deuces.